Today we released Lyra 2.0, a framework for generating persistent, explorable 3D worlds at scale from Nvidia Research. Generating large-scale complex environments is difficult for AI models. Current models often forget what spaces look like and lose track of movement over time.
The final intervention is a self-augmentation training scheme. Instead of training the network on perfect ground truth frames, Lyra 2.0 stochastically conditions the model on its own one-step denoised predictions. By exposing the model to the exact error distributions it will encounter during generation, the network learns to actively suppress drift rather than propagate it. These distinct anti-forgetting and anti-drifting mechanisms converge into an interactive exploration interface.
This is pretty amazing.
Users define long-horizon camera trajectories. This triggers the retrieve, generate, and update loop, allowing the model to endlessly expand the initial seed image into a continuous environment. There is one final operational hurdle. Even with these controls, generated video sequences harbor minor multi-view inconsistencies that easily break traditional 3D reconstruction pipelines. To lift the 2D video into a robust environment, the generated sequence is passed to Depth Anything v3, a feed-forward 3D Gaussian splatting foundation model. Because this reconstruction model is fine-tuned directly on generative data, its multi-view prior is conditioned to ignore minor visual artifacts, outputting clean and coherent 3D structure. The resulting spatial geometries achieve scale, transforming a single input view into expansive, explorable maps. These generations maintain strict structural coherence across the entire camera trajectory, completely eliminating hallucinated layout breaks. Finally, these Gaussian environments can be extracted into hierarchical sparse grid surface meshes, ready for direct deployment in embodied AI platforms like Nvidia Isaac Sim.
Wow.
Lyra 2.0 proves that to build infinite, persistent worlds from a single photograph, an AI architecture must abandon rendering the past and instead learn to mathematically route it.
Wow, just amazing. It's like, I want to just keep listening to this, watching this again and again, then even reading the paper. I mean, just look at how it's actually been able to put this concept from the paper to an amazing cinematic video. I think this time I chose the cinematic video. That's why you have these amazing illustrations. Let me just listen to it for maybe the next 15-20 seconds. Even the introduction it gave was pretty amazing.
We begin with a single static photograph. The goal of generative reconstruction is to use this initial 2D image as the seed to generate an entire explorable universe. To do this, engineers use camera-conditioned video diffusion models. These networks synthesize dense, novel views, which are then used to extract explicit 3D geometry.